Hey guys, this is the lecture for section 6.5. This is the last section in chapter 6, so it's the last section over matrices. We're going to learn two different things today. We're going to learn determinants, and then Cramers Rule, which uses determinants to help us solve systems of equations, which is actually really cool and helpful. So before we do all of that, let's come over here and let's learn what in the world is a determinant. There we go. So we're just going to talk about determinants of 2x2 matrices. There are determinants of other size matrices, but it's a lot easier to just deal with the 2x2s. And since it's really mostly what we've played around with this semester, we're just going to stick with the 2x2s. So given a regular 2x2 matrix where A, B, C, and D, the determinant is denoted by vertical bars instead of the matrix C brackets. We usually say vertical bars with the units in there. And what is it? The determinant is AD minus BC. And we usually denote the determinant with a capital D. So what are we going to do? Well, let's do two examples to find the determinant. We have the matrix 5, 6, 7, 3, and we need to define the determinant. Well, the determinant is AD, so that's 5 times 3 minus our B, which is 6, times our C, which is 7. That's 15 minus 42. Which equals a minus 27. So the determinant for that first matrix is a minus 27. And that doesn't really tell you much right now. It's just that the determinant is a helpful tool, specifically with Cramers Rule, that we'll do in just a minute. So again, we have A, which is 2, times our D, minus our B, times our C. Negative 10, and we have a negative 4 and a negative 3, which will be a positive 12, which will give me a positive 2. That's all there is when you're finding determinants. That's it. It doesn't get harder than that. We're going to use the determinant to solve systems of equations. So in chapter 5, we learned how to solve systems of equations. Now we can use systems of equation or matrices to solve systems of equations. Specifically, we use Cramers Rule to solve these systems. So what is Cramers Rule? Cramers Rule says that the x value, when we solve a system of equations, you know, you get an x and a y value. So the x value is your determinant with respect to x all over your general determinant, and your y value is your determinant with your y's all over your determinant. Again, this is going to sound weird. When you see it, it's going to make a lot more sense. So this is Cramers Rule, with the D being the determinant, with dx being the determinant where your x values are replaced, and the dy is being the determinant with your y values replaced. Again, sounds weird. It's super easy. You're finding the determinant 3 times, and that tells you the solution to your system of equations. It's actually, I think it's really cool because we learned a lot of different methods back in chapter 5, like the addition method and the substitution method, in order to solve these systems of equations. And now we can use matrices to solve them. Okay. So I'm going to take us to the back of the room where I have our two examples of how we use Cramers Rule to solve systems of equations. All right. So we're going to use Cramers Rule to solve this system of equations. If you have a hard time seeing that, because I feel like it's hard to see, remember you can always pull up my notes and see it there. It says 5x minus 4y equals 2. 6x minus 5y equals 1. This is our system of equations. What we are able to do is we can write our system of equations as a matrix using the coefficients of our x and y values. So I can write that as 5, -4, and 6, -5. We've done that in chapter 6 where we solved our systems of equations using our matrices. And so hopefully that's not a huge stretch on how I got that. Now the first thing you're going to want to find, so step 1, I guess, is you want to find the overall determinant. So we're going to find the determinant of this matrix. Well, that's A, which is 5, times your D, which is -5, minus your B, which is -4, times your C, -25, plus a 24, -1. So my determinant is -1. Step 2, you want to find your dx. Now, oh, don't know what happened. Oh, for some reason it shot you over for some reason. Sorry about that. So your dx, according to Cramers rule, that is your determinant with your x values replaced. So I'm going to write my matrix, but I'm not going to write my x values because I want to show you what it means. We're going to replace our x values. But what are we going to replace them with? We're going to replace them with what's to the right of our equal sign. So instead of writing 5 and 6, I'm going to write 2 and 1. We're replacing them with our solutions. And now I find the determinant of this matrix, and that will be my d of x. So my determinant is 2 times -5 minus a -4 times 1. It's -10, and that's a +4. So my dx is a -6. And my d was a -1. I'll circle those so we can kind of keep track of where they're at on the board. Now I do the exact same thing in step 3, only I'm finding dy. So I'm going to write my x's, and I'm replacing my y values with the 2 and the 1. And then I find my determinant the same way. 5 times 1 minus 2 times 6, 5 minus 12 equals -7, and that is my dy. Sorry, this chalk is really squeaky. They didn't have any of the good chalk. So we found our d, we found our dx, we found our dy. That's what we have to do because Cramers rule says that our x value is our dx over our d. Well, our dx was -6 and our d was -1, so that tells me my x is 6. Cramers rule told us our y value was dy over d, and our dy we just found was -7, and our d was -1, so that equals 7. So the solution to the system of equations is the point 6, 7. And we found that using Cramers rule and matrices. We could have done it just like we did in chapter 5, where we used the substitution or the addition method and solved it. But if you did that, you'd get the same solution. And I honestly think this math is quite a bit easier than trying to keep track of all those equations. So I think Cramers rule is pretty good. Okay. We're going to do the same thing on this example. We're going to use Cramers rule to solve the system of equations. So we have 5x plus 4y equals 12, and we have 3x minus 6y equals 24. So the things you're wanting to find are the d, the dx, and the dy. Because Cramers rule says that x equals dx over d, and y equals dy over d. So our determinant, we just write 5, 4, 3, and -6. You write your coefficients of your x's and your y's. You take your A times your D minus your B times your C. Negative 30 minus 12, negative 42. Now for my dx, I'm going to replace my x values with the solutions. So instead of 5 and 3, I'm going to write 12 and 24, and then 4 and negative 6. 12 times negative 6 minus 4 times 24 equals, we're going to get negative 72 minus 96, which equals negative 168. Nice big numbers. Big numbers aren't bad numbers, they're just big. dy, we leave our x's and we replace our y's. We have 5 times 24 minus 12 times 3 equals 120 minus 36, which equals 84. So our x was our dx, which is negative 168 all over our d, which is minus 42. If you type those into your calculator, you're going to see that that's 4. Even though they're big numbers, they reduce down. So that's nice. Y was 84 all over negative 42. Hopefully you can see that that is a minus 2. So our solution is 4, negative 2. And once again, we just solved that system of equations using Cramers Rule and determinants. And that's actually the end of 6.5. That's all we're doing with the determinants. So use the determinant, use Cramers Rule in order to solve the systems.